Thanks, Brandy. We're back here in the Anthropometry and Biomechanics, did I get it right? Biomechanics facility? It's a very long word. We're back with Amy Ross, the spacesuit engineer. Now, you saw before that we had the suit up on the rack. They've actually got Dick Watson in there now. He's pressurized, now he's walking. So talk about this setup, about what we're about to see.
Right, so the ABF has a Vicon camera system.
Okay.
So it's an infrared system that reflects off the little markers on the suit. So we put little reflective markers on the suit.
Dozens of them on there.
And so if you look at the screen, you can see how the cameras see the suit, those markers. And what the ABF, like Liz Benson here does, is they can take those marker sets and analyze the motion of the suit. So we can understand, say, elbow range of motion,
yeah,
or knee range of motion, or how, if you're kneeling, what joints you use and how much. So it really gives us a lot of information about not only the gross mobility of the suit, but how each individual component of the suit contributes to the overall mobility.
Now, people that have seen the movie Avatar or seen Lord of the Rings or any of those know this as motion capture,
yes,
right? Same technology?
Same technology.
Talk about how much that helps you guys design these suits. What does it do? So
it really helps us a lot, because I used to have to do measurements where I'd have the person do as far back as they can here, as far back as they can here, and I just took pictures and measured it.
Yeah.
And now I can have them do functional tasks and actually understand which joints they use and how much that joint contributes to the motion.
Now we're seeing little white dots here. Now you guys showed us this before we came on the air, that they actually build kind of a skeletal model and kind of a false suit, right?
Yeah, so it's a little bit hard. If he moves, you can kind of tell an arm when he moves, but they can build a framework that can show the different segments of the body better.
Yeah.
So you can see an arm, you can see the torso, you can see the legs, more than making it up out of a constellation of dots.
You can actually see in the computer from all angles how he actually moves and how the suit really does operate.
Yep.
Now, you guys were saying that this is down to a millimeter. The cameras can sense almost down to just just a hair.
We have a lot better accuracy than we used to. We looked at motion capture back in the late 90s,
yeah,
and it just couldn't give us the kind of data that we wanted for the spacesuit design work. So it did motion capture for video games, but it didn't help us for the spacesuit design. Now it does.
Yeah, and the green boxes actually represent the cameras. How many? There's what, 8 cameras, I guess, up here?
Yeah, 8 cameras.
8 cameras. This is very impressive to see this. Now, what's happening? What is it doing?
This is actually the rays, and it's basically seeing which of the cameras can see each of the markers.
Okay.
So if you see red coming from a camera, it can see that marker in its individual view.
Okay, so the cameras are actually picking up on that one specific marker, the blue that you see there.
That you can probably check to make sure that you've got enough cameras to get the 3D imaging that we want for any body part.
So how long will this test go on today? I mean, how long is he going to be in the suit?
They've been able to get this test to be pretty efficient, so the test only takes about an hour, hour and a half now. We used to spend 3 hours doing this test, and we used to spend even longer, and then the data analysis took months, whereas now Liz can give us the numbers pretty quickly, which is one of the real benefits of the updated technology. So
to the layman, what you guys do is you record this and you go back and you take a look at it later on, right? You're just looking at range of motion measurement. Do you go back and compare different tests to each other and see how it's improved?
Yeah. One of the main things we do is we look at how the person can move without a suit on versus how they can move with a suit.
Okay.
So we can understand how much the suit does or does not allow them to move as they would want to naturally.
It either inhibits them or helps them.
Right.
Interesting. So do you do walking and
yeah, we try to look at a variety of motions, so we do some isolated stuff that just exercises individual joints to their maximum.
Like he's picking up
but
something
then
right now.
We do kneeling, walking, crawling. So we really try to give some tasks that might be realistic for EVA, or some tasks that we just know really exercise the joints a lot.
Well, this is fascinating. I mean, this is very cool to actually see this, in reality, and see you guys actually, building a suit and practicing it like this. It's quite impressive the amount of effort that goes into this.
Well, this year is very exciting because we do have a lot of testing going on, because we're really trying to understand how this suit moves and works, so we can make those decisions for the next configuration.
Yeah. Well, if you guys want to take a look at the spacesuit development, see some pictures of some of this or anything like that, you can always log on to the NASA website, which is at www.nasa.gov. Amy, thank you so much for joining us. This has been incredibly interesting.